I'm very grateful to be here, and I'm delighted to share my insights on air quality in the Hindu Kush Himalaya region. So firstly, let's talk about the global and the regional status of air pollution. As we know that air pollution continues to be a leading environmental risk to human health worldwide. According to WHO, 99% of the global population breathes air that exceeds safe level, which is a staggering figure. On the following map, countries are color-coded by annual average PM 2.5 concentration ranging from blue to purple, which is good, moderate, unhealthy, very unhealthy, and hazardous. Zooming into the South Asia, the 2024 World Air Quality Report by IQ Air highlighted the region as one of the most polluted global country. Countries like Bangladesh, Pakistan, India, and Nepal consistently rank among the top 10 polluted nations with average PM 2.5 level far exceeding WHO guideline. For instance, Bangladesh annual PM 2.5 average is 15 times higher than WHO recommended limit, while Nepal is 9 times higher. Even though India made modest progress with a 7% reduction in PM 2.5 level in 2024 compared to the data published in 2023, 6 of the world's 10 most polluted cities are still in India, including New Delhi, which shows little year-on-year improvement. Seasonal pollution spikes, especially during winter months, due to crop residue burning continues to create hotspots, particularly across the Indo-Gangetic Plain and Himalayan foothill regions. This trend underscores persistent challenges such as industrial emission, vehicular pollution, construction dust, and agriculture burning, which are deeply rooted and complex. Now, understanding what are the sources and how they come from and where they come from. What is meant by air pollution? It occurs when particles or gases such as PM 2.5, PM10, CO, SO2, NOx, ozone, VOCs, and short-lived climate forces like black carbon are introduced into the atmosphere beyond the standard level. And from where these pollutants come? Talking about indoor air pollution, mostly it occurs from biomass cooking and heating, kerosene, lamp, poor ventilation, household VOCs, which is disproportionately affecting women, children, and elderly. Talking about major outdoor sources includes both anthropogenic sources and natural sources. Talking about anthropogenic sources includes vehicular emission, industries, power generation facilities like bricklaying, steels, cement plants, and coal plants. Agriculture burning of crop residue and open burning of waste are the major anthropogenic sources. Talking about natural source, desert dust storms and seasonal forest fire also contribute significantly to pollutant load. Not only local sources, but also meteorology plays a major factor in pollutant dispersion and formation, especially wind pattern, temperature, inversions, rainfall washout, and sunlight-driven photochemical reactions. Seasonally, winter inversion and biomass burning peaks pollution level. Pre-monsoon months carries desert dust, and post-monsoon agriculture fires and festival activities increase air quality crisis. Now talking about PM 2.0 and black carbon. Black carbon is a component of PM 2.5 formed by incomplete combustion of fossil fuel, biofuels, and biomass, posing serious threat to both human and climate. According to World Bank report, outdoor PM 2.5 pollution contributed to an estimated 4.1 billion premature deaths in 2016, while household air pollution was responsible for 3.2 million deaths in 2020. Further, black carbon also affects climate with a warming potential up to 1,500 times that of CO2 per unit mass. This extreme forcing occurs because black carbon particles absorb solar radiation, and when deposited on snow, ice, it darkens the surface, reducing reflectivity and accelerates melting. Although black carbon remains in the atmosphere for just 4 to 12 days, its short-lived nature makes it powerful near-term climate forcer. In 2019, globally, black carbon emission reached 5.8 million tons, nearly half, 43% of which streamed from household energy use alone. The figure on the right shows regional contribution of black carbon emission, with 60% of emission in the South Asia coming from residential fuel combustion. By targeting short-lived climate pollutants, we can lower global warming by 0.6 degrees Celsius by 2050, protect snow and ice, curb sea level rise, avoid premature deaths, reduce air pollution, and improve agriculture productivity, as was reported by Climate and Clean Air Coalition. Lastly, calling for an action to effectively improve air quality in the Hindu Kush Himalayan region, fostering multi-stakeholder collaborations is essential. Bringing together government partners, communities, researchers, and industries to co-design and implement solutions. Investment in clean technologies such as electric vehicles are also important. Strengthening institutional capacities through national air quality bodies and regional mandates will ensure coordinated monitoring, shared standard, and harmonized policies across borders. Equally, it is important to promote knowledge sharing, evidence-based actions, and public awareness. To maximize impact, air quality prioritizers must be mainstreamed with climate, health, and development policies, unlocking financing and amplifying co-benefits. Finally, scaling sectors, specifically interventions with dedicated fund and active private sector engagement, will accelerate adoption of green technology, especially when clean standards and initiatives are in place. Just ending my presentation here. Thank you.